Okay, pre-cal, we are going to continue looking at velocity vectors here and their component forms. So we're going to look at example 4 here. We are told to find the component form of the velocity vector. That means it's going to look like this, that represents for our specific situation an airplane descending west at a speed of 100 miles per hour and at an angle of 30 degrees below horizontal. All right, so let's consider this. North, east, west, south. Okay, if the airplane is descending west, that means it's coming down this way. West at a speed of 100 miles per hour and at an angle of 30 degrees below the horizon. So west 30 degrees below the horizon. That is what that would look like. Okay, so if we want the component form of a velocity vector, we need two things. We need the speed and we need the direction angle. That's what we need. Okay, so let's find the direction angle first. That's going to be the easiest part. All right, well, it's not the easiest part because the speed's given to you, but you know what I mean. All right, so remember how we find the direction angle. We start at the positive x, we move counterclockwise to the vector. I didn't have to calculate the reference angle because I was given the reference angle already. So the direction angle is 180 degrees plus 30 degrees. So the direction angle is 210 degrees. I know that the speed is 100 miles per hour. So I'm going to use this format right here. The speed is 100 times the cosine of the direction angle, and 100 the speed times the sine of the direction angle. Okay, this is how I'm going to calculate this. So I'm going to go to Desmos. Oops, that's not what I meant to do. Go to Desmos. There we go. I've got it together. And I'm going to type in exactly the value. 100 times the cosine of 210 degrees and 100 times the sine of 210 degrees. And it's okay that these are negatives because I'm not finding angle measures, all right? The angle measure was 210. So my values are negative 86.6 and negative 50. So let's go back to our problem, and I'm going to write that up here, negative 86.6 and negative 50. All right, that is it. That's all I have to do. I want you to notice that this vector is in quadrant 3. So it makes perfect sense that I have a negative for both my x component and my y component. These values represent moving from the origin left 86.6 and down negative 50. That is what we're finding, okay? So don't freak out. See, it's not horrible. All right, let's look at example 5. The speed of a plane is 200 miles per hour. The direction angle is 225. You're given the direction angle. You don't even need to do anything but this right here. So the component form of my vector is 200 miles per hour times the cosine of 225 and 200 times the sine of 225. That's all you have to do. Now they're not all that easy, of course. So 200 times the cosine of 225 and 200 times the sine of 225. I get negative 141.4 for both of them. So now we're going to talk about what that means. So negative 141.4 and negative 141.4. Okay, I want you to think about this. If I go 225, doesn't that make sense that these should be equal to each other? Because 225 is 45 degrees into quadrant 3. See? Pretty cool, huh? And it makes sense that they're both negative because we're in quadrant 3. Easy peasy. All right, let's look at example 6. It's a little more challenging. You're welcome. All right, so I'm going to switch colors here. And I'm going to draw my XY coordinate plane because this one is going to be, you know what, I don't need it to be quite that big. This one's going to be a little bit trickier. North, east, west, south. Okay, so we have a jet flying on a course of north 40 degrees east at a speed of 430 miles per hour. There's a strong wind blowing 50 miles per hour in the direction south 20 degrees west. Draw a picture and find the component form for both the wind and the jet. So you're going to have two answers here. You're going to have an answer for the wind and you're going to have an answer for the jet. So I'm going to deal with the jet first. And it doesn't matter which one you deal with first. Okay, so we're going to deal with the jet first. It has a course of north 40 degrees east. Okay, so this is 40 degrees right here. All right, and it is moving at 430 miles per hour. So the jet, component form, the speed times the cosine of the direction angle, which I don't know yet, and 430 times the sine of the direction angle. Remember, babies, the direction angle starts at the positive x-axis and moves to the vector. This is the direction angle. Well, if this is 40, then the direction angle is 50. Easy peasy lemon squeezy. So the jet is 430 times cosine 50, 430 times sine 50. I'm going to go to Desmos. 430 times cosine 50, 430 times sine 50. So I get 276.4 and 329.4. That's what I get. So I'm going to go back to my problem. I'm going to write that down. 276.4, 329.4. Again, pay attention to what this means. We're in quadrant 1, so it makes sense that for the jet, both of these values are positive. 276.4, 329.4. You with me? Okay, so now let's look at the wind. I'm going to need a separate picture for the wind. So let's use a different color. Okay, for the wind, it's got a direction of south 20 degrees west. And it's got a speed of 50 miles per hour. So the wind is 50 miles per hour times the cosine of the direction angle, don't have that yet, and 50 times the sine of the direction angle. Okay, finding the direction angle for this one is going to be a little trickier because it's not in quadrant 1. So remember, for direction angle, I start positive x, I go to the vector and stop. So it's 180 degrees plus this angle. Well, if this is 20, and I know there's 90 degrees in my quadrant, then this is 70 degrees. So 180 plus 70 is going to give me 250 degrees. I'm going to calculate this in Desmos. 50 times the cosine of 250. 50 times the sine of 250. Oops. Oh, man. Sorry. Okay. So I get negative 17.1 and negative 46.98, or you can just call it negative 47. All right. So negative 17.1, negative 47. We're in quadrant 3. Makes sense that they're both negative. Life is good.